I want to now describe how the flow of chapter 1 in this book and what you should be thinking about as you read it. The first thing we talk about is the historical framework for the subject of the critical zone or Veda zone processes. And we go through, in a timeline sort of framework, how the field emerged. And what this does is it naturally builds an overall context for everything we're going to learn in the class and everything that's going to be in this book. And so it gives you a place to hang all your ideas, and it gives you an appreciation of how the field developed, which explains actually why certain things follow other things and why certain terminology and notation are still employed. So the historical framework we find is a very useful place to start, giving you a context for everything that's going to be in the book. A key thing that we want to emphasize is the distinction from saturated systems. And so what are some of the key distinctions you want to keep in mind? One thing is that saturated systems have a conductivity, which is usually the saturated conductivity, whereas unsaturated systems, the conductivity depends on the moisture condition of the system. So this is a saturated system, and this is the unsaturated system. And another thing is how diffusion works. In saturated systems, it's dominated by liquid phase diffusion, where in unsaturated systems, it's typically going to be dominated by the gas phase. And the thing is here is the gas phase diffusion coefficient is about 10,000 times larger. And that has a lot of implications for how things are going to move in the system. Finally, what is the temporal nature? And what we see in saturated systems, the system is essentially static in its overall properties, whereas in unsaturated systems, in time, everything may change with movement of water through the system. All the pressures and the properties of the system are variable. So there's a fundamental set of differences between saturated and unsaturated systems. We want you to get that because many of you are coming from a class framework or a study framework from saturated systems. So you have to really be clear about some of these key differences. Then we finally start to talk about soils themselves. And soils have been described for hundreds of years, and there's now a really cool framework for describing soils and a whole methodology for dissecting and defining the properties of soils. And so first thing we have to do is understand how the world views soils so that we can use the same terminology they do. And then we spend quite a bit of effort at the end with the hidden giant, we call it, which is clay. Clay is where most of the surface area in soils are and where a lot of the control on the hydraulic properties of soils are, because the clays are highly resistant to flow when they're stacked up. They are the smallest particles. They define the fine pore structure oftentimes. So the clays are highly reactive, high surface area, and control a lot of the permeability. And so we take some time to understand the chemistry and the physics of these clays. Overall, what we're trying to do is give you a framework in which you can understand the intrinsic variability of soils, how soils are described, and provide a context for all the information that's going to come in the later chapters. And that's the overall kind of objective of chapter 1.